Oh, there we go. Alexis asked a really good question about the homework. I think, could you remind me what the homework question said?
It's part 4. It says between what two values are the middle 90% of the diameter? It says the middle of the 90 diameters. The middle 90% of the diameters occur between 1 millimeters and 1 millimeter.
Mm. And what was like the mean and standard deviation of that problem?
The mean was 25.2 and the standard deviation was 0.07.
Awesome. Okay. So this one is something that you can do with the tools that we have right now, but it requires a little bit more work, and I didn't really go through something like this question before. So let me just kind of draw a picture of what we're dealing with right now. Okay. So of course we're dealing with the normal distribution, so probably a good idea to draw a normal curve, right? And I guess the middle 90% of the data, if I were to shade it in, would be something like this, right? It'd be the middle, and everything in between would represent 90% of everything in the data, right? Okay. So Minitab can't do this, right? It's not very smart with like between probabilities. And yeah, and it's kind of hard to kind of visualize what we're doing here, okay? First of all, let's try to figure out what sort of problem this is, right? I think we're given a probability here, right? And we're trying to find this value and this X value, right? So do you think this is a cumulative probability question or an inverse cumulative? Like what would we click as our options on Minitab? Like, are we trying to find the probability or are we trying to find the inverse, right? Because we're trying to find the X value. We're not trying to find the probability. So this is definitely an inverse cumulative. Type problem, right? So this is the sort of problem that we're dealing with here, okay? Now, the main question is, what are these X values, right? What's going on here, okay? Now, Minitab's not gonna be able to spit out two X values. So I think what we should do is first, we should try to find the lower one, and then later on, we'll find the other one, okay? So first we'll find the left one, then we'll find the right one, okay? So let's try to find the leftmost value. So if I were to draw my normal distribution and isolate that left one, it'd be this value here, right? Okay. I wonder if there's a way to find this probability here, because if I found that, then I could plug it into Minitab really well, right? Well, in the middle we have 90%. Okay. I'm going to ask you a question. If I were, let me try to do this in a different color here. I'm going to shade things in pink here. Okay. I'm going to shade in this area and this area. So I'm shading in everything that hasn't already been shaded in. Okay. Can someone tell me the area or the probability underneath what I've shaded in pink? Yes.
5%.
Okay, I think you're a step above me. You're a step ahead of me. 10% total, but then 5% in each section, right? Yeah. So everything that I've shaded in, including both of them, is 10%, right? Okay. So both of the sides are 10%. Then, okay. If I were just to focus on this one, like Alexa said, this would be 5% because we're splitting it in half. Does everyone kind of see how we found that little edge? Okay, cool. So that means this is 5% of the data. Okay, now Minitab doesn't like percents, so let me just change that to 0.05, a decimal, right? Okay, so here's my hint for finding the leftmost one. Okay, what we're going to do is we're going to use inverse cumulative. Okay, when you're typing in the mean and standard deviation, you're going to type in the 25.2. Standard deviation is 0.07. Okay, and under input constant, well, we isolated this problem to a less than 0.05 question. So we're going to type in 0.05. Okay, whatever number pops up is going to be our first number. Okay. So questions on finding the left number? All right. Now, let's go on to the second number. Okay. So if I were to draw my normal distribution and just copy that left hand or the right hand number here, it would be here, right? Okay. So basically this question is asking us to find this number, right? Okay. Let me shade this in. Anyone want to guess what this probability is going to be? What do you, sorry, I didn't hear.
5%.
Okay, 5%. Oh, so you're saying this is 5%, right? Okay, what about the left-hand side? 95, good. Awesome job, okay. So remember, Minitab only likes less than probabilities. It only likes when we shade things to the left. So I'm actually gonna use the 95% in Minitab instead of the 5%. And let me just change that to a decimal because Minitab likes decimals. Okay, so my hint for you in this one is to type in inverse or to use the inverse cumulative. Okay, make the mean equal 25.2. Make the standard deviation equal to 0.07 and the input constant be 0.95. So that would be your second number. Does this give you a better idea on how to do that problem? Awesome, awesome. Yeah, I completely did not see that on the homework. So thank you so much for bringing that one up. We're actually going to be using problems like this in the future too. Okay. All right, let's move on to our guided notes from last time. Okay. Does anyone need a copy of the guided notes? All right. Let's get back into the mindset of the type of problem we're dealing with now. Okay, so before we kind of did basic probability questions, now we're going to talk about what we call sampling distributions or the distributions of the sample means. Okay, whenever we have a question that asks us, what's the probability that the means are less than this or greater than this? This is the type of section that we're going to. Okay, so we did a little example with tetrahedral dice. We talked about the differences between the populations and the sampling distribution or the distribution of the sample means. Okay, and we realized that the mean of the sampling distribution will have a mean, the mean of the means equaling the actual mean, and the standard deviation of the means equaling the standard deviation over the square root of n. Okay, so these two formulas are very, very important. Okay, and we also talked about the probability distribution of the means. Okay, so the sampling distribution of the means, probability distribution of the sample means, will have approximately a normal distribution if our sample is large enough. Okay, now if that doesn't make sense, I think as we move on, it'll make a little bit more sense. So don't freak out if this isn't making sense yet. But let's just go to this example here. Okay, this is a very typical example when we're talking about sampling distributions, distribution of the sample means. I actually kind of want my notes here. Okay, and up top here, what I'm going to do is I'm going to rewrite the two formulas that were on the previous page. Okay, so when we're talking about the mean of the means. Okay, remember we used the mean form or the mean symbol with the sample mean symbol right below it. Okay, and this was equal to the actual mean. Okay, whenever we're talking about the standard deviation of the means, we're going to use this symbol with the mean symbol below it. And we're using this formula here, the standard deviation over the square root of n being the sample size or how many things are in this. Okay. Let's read this example. Students are at a certain college. The mean hours of television watch is 10.5. The standard deviation of television watch is 3.6. We took a simple random sample of 16 students and we tried to look at their viewing habits, okay? So we are going to let X bar, okay, I kind of extended that bar if you don't see it, be the mean number of hours of TV watched by the sample students. We want to find the mean of the means and the standard deviation of the means here, okay? So what I'm going to do over here on the left is just write everything that I've been given from the problem, okay? I feel like this prevents me from messing up in the future, okay? So I guess the problem gave us that mu, or the mean, is equal to 10.5. And it also gave us that sigma, or the standard deviation, was 3.6. Okay. Now, on the right-hand side, let's find the new mean and the new standard deviation. So given my two pieces of information, what is mu sub x bar? What's the mean of the means? Well, if we take a look at the formula here, it says it's equal to mu. So what is the mean of the means in this example? 10.5, awesome. Also, it's just the same number, right? So not too bad. Okay. Oh, I also forgot to add in my list of things what the sample size is. Well, we have a simple random sample of 16 students, so I guess n is 16, right? Okay. So just like the last problem, if I wanted to find the standard deviation of the sample means, I would have to plug it into my formula, sigma over the square root of n, right? And just by plugging in my numbers, I would get 3.6 over, yes, the square root of 16, okay? And if you type this in your calculator, you'll probably get something like 0.9, and that's your standard deviation. So does anyone have any questions about finding the new mean and the new standard deviation of the sample means? Awesome, awesome. Okay, so I have a lot of words down here. You can feel free to read them later on, but what I kind of want to do is give an introduction to this really, really important topic in statistics, okay? So basically, for any sample, okay, if the sample size is large enough, okay, the sample, the distribution of the sample means, or the sampling distributions, is going to look approximately normal, okay? And let me give you some examples of where this is true, okay? Here we have a sample size of n equals 3. This histogram over here is the distribution of the means for the sampling distribution. Well, this one doesn't look very normal to me, right? Okay. If we increase our sample size to 10, well, our distribution is looking a little bit more normal, right? And once we increase our sample size to about 30, well, we're getting something that looks very obviously like a bell curve or a normal distribution, right? So let's try to think about this. If the sample size is large enough, we're going to have something approximately normal, okay? Now here's the catch. If our sample just regular in the population, or sorry, let me rephrase that. If our population is approximately normal from the beginning, okay, the sample size doesn't matter, okay? let's put this all together, okay, into one big theorem here. Okay, I know this was a lot of words thrown around. We're actually going to put this together very concisely in this thing called the central limit theorem. Okay. Now, what I want you to do is highlight around this theorem, put a box around it, okay? Because this is actually the most important theorem in all of statistics, okay? If you ask any statistician out there and ask them what the most important topic of statistics, it's this one right here, the central limit theorem, okay? So let's read what this says, okay? We're gonna let X bar be the mean of a large enough random sample, okay? So by large, we mean that the sample size is bigger than 30, okay? So if the sample size is bigger than 30, then the means, the sample means, will have an approximately normal distribution with our new mean and our new standard deviation, okay? So if we have a large enough population, our means will have an approximately normal distribution. Okay. Now, there is a catch here at the bottom. If her population is symmetrical, or if it says a normal population, okay, any sample size will suffice, okay? So for example, we could have a sample size of 2 and our population be normal. The central limit theorem would still apply. Our means would have an approximately normal distribution as well. Okay. I feel like this theorem is kind of hard to read. So what I've done down here is gave a few different examples of things that can happen. I want you to figure out if we use the central limit theorem or if we don't. Okay. So if things aren't making sense yet, don't freak out. I think these examples will kind of clear things up for us. Okay. Let's read this one. Example 1. We have a sample size, a sample of size 45. So n here equals 45. Okay. We're drawing this from a mean or from a population that has a mean of 15 and a standard deviation of 3.5. Okay. So the question here is, does the central limit theorem exist? Or basically, is it appropriate to use the normal distribution for the probabilities of X bar? Okay. So let's go back to this. The big criterion here is, well, is n bigger than 30? Is n bigger than 30 here? Awesome. Okay. So n here is bigger than 30. We don't have to do any more work. The answer is yes. Okay. Let's take a look at another one. Okay. Example 2, we have a sample of size 8. We're drawing it from a normal population. The mean is -60, standard deviation is 5. Let's see if it's appropriate to use the normal distribution to find the probabilities for X bar, okay? Our sample size here, well, what is our sample size? 8, right? Is that bigger than 30? Okay, not bigger than 30. Can we use the central limit theorem here? I think it's yes. Yes,
You could use it, but it wouldn't be necessary.
And why do you say that?
Because it says that it's a normal distribution.
Yes.
Normal population.
Okay, so I like how you realize that it says normal population. Let me just highlight that here. Okay. So I like that. The answer actually is yes. Okay. Okay. Even though the sample size is not bigger than 30 here, if the question says normal population, we can still use the central limit theorem. So yes, because, not because of the sample size, but because the question says normal. Okay. So let's take a step back here. Okay. Example 1. We didn't have to look to see if the population was normal because the sample size was already bigger than 30. Okay. Example 2, we had to check the sample size, and since it didn't work, we checked in the question to see if it said normal. We were good.
So I'm a little confused about what you're trying to ask us here.
Okay, yeah, so the question, yeah.
Are you asking, like, should we use the PLT, or are you just saying, like, is it a normal distribution?
Kind of like both, okay? So yes, the big question here is, does the central limit theorem apply? Can we use the central limit theorem, okay? But what the central limit theorem says, or the conclusion of it says, sorry, I'm trying to scroll up at the same time, is that the sample means have an approximately normal distribution. So when you're answering questions about the probability of the means, we can apply this theorem, okay? If it doesn't apply, we can't answer the question at all because we don't have the tools to use it, okay? So two different questions here. Does the central limit apply? This process will answer that question, okay? This will also answer the question like, let's say, what is the probability that like the sample mean is bigger than 2? Okay, so if your question on website asks you, like, what's the probability of the sample means being bigger than 2? Or what's the probability that the sample means are less than or equal to 3? Okay, whenever we're answering questions about the sample mean being bigger or less than something, we're going to ask ourselves first if the central limit theorem applies. Does that answer your question?
I think so. So we can only use those things at the top only if it's the requirements of that. So
Yes. And if you're still like kind of on edge about this, I think when we do like an actual calculation step, I think we'll kind of process. This is the most important theorem. There's a lot of caveats in it. We have to kind of get to an example first. And I think once you get to that example, you'll be like, okay, I know how to do this problem. Okay, let's keep going. Here's a final example just to see if the central limit theorem applies or if we can answer questions with the tools that we have so far. Okay, so first, we have a sample of size 24. So n is 24. And it's drawn from this population with this mean, standard deviation. We're asking if it's appropriate to use the normal distribution to find probabilities for X bar. Okay, well, 24 is definitely not bigger than 30, right? Okay. Is there any mention of a normal distribution here? No, no mention of normal. Okay, so since we have both of these two things, not bigger than 30 and no mention of normal, can we use the central limit theorem? No, right? Can't use the central limit theorem. Okay, so whenever we're answering questions about the probabilities of the sample means, our first question is going to be, okay, can I use the central limit theorem? If the answer is yes, we can go on ahead. If the answer is no, then we can't answer the question at all. Okay. I'm sorry for making you bear with me until we get to examples, but I think once we get through this example, it might make things a little bit easier to process in the future. Okay, so let's look at this example. We have data from the US Census, and this data indicates that the mean age of college students is about 25 years, okay? So let me just write this down here so I have it. Okay, the mean is 25. And it says that the standard deviation is 9.5. So I'm going to write that down too on the side. Okay, we're going to take a simple random students of 125 students. Well, that's n, right? And we're going to find the probability that the sample mean age of the students is greater than 26 years. Okay, let's take a step back from that last line in the question. So this line is asking us about the probability of the sample means, okay? So this is a very important part of our question, okay? Since we're not asking about the probability of something being bigger than a number or less than a number, it's specifically asking about the probability of the means. This is the biggest hint that we are using the central limit theorem. Okay, so whenever it's like, what's the probability of the means being bigger than this? Central limit theorem. Okay. All right. So the first question we need to ask ourselves is, can we use the central limit theorem? Okay, well, who thinks we can use the central limit theorem? And why is that? Awesome, awesome. So yes, because 125 is bigger than 30. Awesome. So step one is done. Okay, here's my next step. Okay, we're asking about the sample means. The sample means, or the sample means don't have the same standard deviation as the standard deviation in the question, right? We have to find our new mean and our new standard deviation using those two formulas that we went through in the beginning of class. So can someone tell me the new sample mean? Awesome. It's the same as the regular mean. And how would I find the new standard deviation? What's the formula here? It's a fraction over square root of n, good. And up top we have the regular standard deviation, okay? So all I have to do is plug in my standard deviation and n in here. I have, oh my goodness. I've got 9.5 over the square root of 125. If you do this in your calculator, you should get something around 0.85. Okay, so what we've done is we found a new mean, we found a new standard deviation, okay? Step three. Okay, step three, let's just figure out what this problem is even asking us. Okay, we want to find the probability that the sample mean, or x bar, is greater than 26. Okay, so this is definitely a greater than question. It's not a less than question. And we're asked to find the probability. Okay, now if we were to use Minitab, are we going to use the cumulative probability or the inverse cumulative? So are we finding a probability or are we finding the x value here?
Upstairs to security. You have a buzz cruising.
Oh, I think someone's mic is off. Oh, I'll just, okay, there we go. Oh, very good. So we're definitely finding the probability, right? We're finding the probability that something is bigger than 26. So we're going to use the cumulative probability, right? We're going to use the cumulative probability option, okay? Under the mean, we'll type in Minitab 25. Under the standard deviation, we're going to type in the 0.85, right? Okay. Now under input constant, we can type in 26, right? But will that give us our final answer? No. And why is that? What sort of question is this? This is a bigger than question, right? So Minitab can only answer less than questions, right? So when we type this in, it's going to give us the probability that the sample means are less than 26, right? So we can get this number, but our final answer is going to be 1 minus the number, right? All right, let's go into Minitab. I'm going to have to open up Minitab on my computer. Forgot to do that. See? All right, I'm going to share my screen. Okay, remember to find normal probabilities, we go to Calc, Probability Distributions, and then Normal. I guess it's up here. Okay, then we get this pop-up window up here. There you go. We're going to click Cumulative Probability, just like we said on our notes. The mean is going to be 25. The standard deviation is now 0.85. Okay, and under input constant, we're going to type in a 26. Okay, I'm going to hit OK. And our probability is 0.8802. So this is the Minitab output. So I'm writing this down on my notes. I'll come back to it later. Okay. So Everyone good with what I typed into Minitab? Awesome. All right, I'm going to stop the screen share. I know it's kind of annoying going back and forth. 3, 2, 1, go. And go back to good notes. Okay, so I just wrote out the Minitab output here, which ended up being 0.8803. How do I find the final answer? Good, subtract from 1. So final answer is 1 minus 0.8803. And I am very bad at mental math, and I don't know where my calculator is. So I'm gonna go type this in real quick. 1 minus 0.8803. That ends up being 0.1197. Okay. Any questions on how I got to this probability over here? All right. So let me make this full screen. Okay. Let's go through example 2. So similar type of problem, we're just going to go over the process again. I know there's a lot of steps here, so I feel like we should do another problem just to make sure that we're good with what we have here. Okay. So example 2 talks about Hereford cattle. These are the most popular breeds of cattle. Didn't know that before. Okay. So based on this Hereford Cattle Society, we have the mean weight of 1-year-old cattle or a 1-year-old bull is 1,135 pounds. So let me just write that down on the corner. Okay, and it tells us that the standard deviation is 97. So of course, I'll write that down too. Okay, now this question isn't asking about a probability, but it's asking us if it's unusual for the mean weight of 100 head of cattle to be less than 1,100 pounds. So I guess N is 100. Okay. So looking at this question, how do we know that this is a central limit theorem question? What about this question gives it away? Oh yeah. So this one, definitely the central limit theorem applies, but how did I even know to check if it's bigger than 30? Alexis?
It's asking for the mean weight.
Yeah, we're asking about a probability or like the unusualness of the means, right? So when it's asking about the means, this is our big hint that we're dealing with a central limit theorem problem. Okay, so this is definitely not something we just type into Minitab. We have to find those new means and new standard deviations first. Okay, so we already answered our first question, right? Can we use the central limit theorem? The answer is yes, because we said that 100 is bigger than 30. So we're good on the central limit theorem. Okay. Step 2 is to find our new mean and our new standard deviation. Okay, what's the new mean? Good, 1,135, which is our old mean, right? And our new standard deviation is found using that formula again. So sigma over the square root of n. Okay, cool. Sigma is 97, n is 100. So when you type this in, you should probably get 9.7 on your calculator. So we found our new mean, our new standard deviation. These two are the numbers we're typing in the Minitab as our mean and standard deviation. Okay. So let's go to our third step here. Third step, we're going to rephrase what this question is asking us. We're going to try to figure out what exactly we're doing. Is this a less than problem, a greater than question, things like that. Okay. We want to find the probability that the mean weight of 100 heads of cattle is less than 1,100 pounds. Okay, so we want to find the probability that X bar, or the sample means, is less than 1,100. Okay. So I guess what we need to do is type stuff in a Minitab. Okay, is this a cumulative probability or a inverse cumulative probability question? What do you guys think? Alexis?
Cumulative, because it's asking for the probability.
Awesome, awesome. So this is cumulative probability. Okay. When we go into Minitab and type in our mean and standard deviation, we're going to type in our new mean and our new standard deviation. So the mean is 1,135. The standard deviation is 9.7. Okay. And on the input constant, we're going to write 1,100 because that's the number that we're interested in finding the probability of. Okay. So when I type this into Minitab, is this going to be our final answer or do we have to subtract from 1? Yes, it's going to be our final answer because this is a less than probability. Nice job. Okay, let's go to Minitab. I'm sorry for having to go back and forth here, but this is what we're doing. We're going to go and click Calc, Probability Distributions. We're going to click Normal. Okay, now cumulative probability is kind of already saved from last time. It's the mean is now 1,135. The standard deviation is now 9.7. Awesome, nice job. And the input constant is going to be 1,100. Let's click OK. So, our probability is really small, right? It's 0.0001541. Okay. Any questions on the Minitab steps here? Nice. Okay. I'm going to have to go back and share my screen one more time. I promise this is the last time. 2, 1, go. All right. You can look at my weird selfies I take on my iPad. Okay, so our cumulative probability ended up being, was it 0.0015? Was that what it was? Oh, okay, 0.00015. Okay, this is what Minitab outputted, right? And it also is our final answer. This is our final probability. Okay, now we haven't finished answering the question yet, right? The question asked us, would it be unusual for the mean weight to be less than 1,100 pounds? Who thinks it'd be unusual? Nice. And why is that?
It was less than like something 5.
Yeah, like this probability is really, really small, right? It's like I don't know, it's 0.1% or maybe is it 0.01%, I think. So yes, it would be unusual. Okay, and the reason behind this is because the probability is really, really small. Is very small. Okay. So, any questions on this example here? All right, well, that kind of sums it up for the central limit theorem. Very important theorem, and it's very important to tell if we're using the central limit theorem in a question or not using one in a question. But remember, just check to see if the question is asking for the probability of something or the probability of the means. Okay. Does anyone have any questions for me? All right, well, I hope you guys have a wonderful spring break. Try not to do as much math during the break. And yeah, and if you need an extension, if you guys are coming home or you're on Zoom or something, just let me know. I know I kind of made the homework deadline a little bit short here. But yeah, let me know if you need extension. But have a nice spring break. I'll see you, I guess, 2 Mondays from now. All right.